Wow, super tired.
Yeah, I can relate to that.
Yeah, me too. A lot of stuff.
Yeah, lots of things happening. Good thing the weekend's coming up. Do you guys have a break on the weekend?
Kind of.
Time to develop.
Yeah, kind of. I'm trying some personal projects, so in the end, use the weekend for doing more
Yeah.
stuff.
Yeah, weekdays are for meetings, weekends for coding. Hi, Santiago.
Hi, how are you?
Oh, I'm good. How are you doing?
All good, all good.
So today I have a little, it's not quite so structured, it's more going to be a full collaborative build session, but that should be fun.
Cool.
Where did we leave last time?
Last time we had just put the conviction, we basically had the parameters outlined, in the widgets. So I've taken that a bit further this time. I want to actually have those parameters connected to visualizations. So I've made a simple example for the dandelion voting. Okay, yeah, I guess this is, we're a few minutes in, so I think I'll just get started. Okay, so I've got here, like always, the, so from Tech Labs, pinned channel, then you can find the Notion workspace. So everyone should go ahead and open that up. And go ahead and open up the attendance sheet. We'll get some emojis going. Insert row.
Sorry, where is it?
So the best way to go is probably in the Tech Labs channel here in Discord. And then the pinned messages at the top. And from there you'll see Notion.
Thanks.
There we go. So this is Lab 6. I think Sem likes nature. Okay, awesome guys. So we got a nice little crew here today. Maybe a couple stragglers coming in. Yep, awesome. Hey Jake, Griff, nice.
Yo!
Hey.
Hello.
Good. So.
Hey. Hey everybody! Before we go, make sure and check. You got Impact Hour tokens for voting. Yes.
So how do we check that?
Well, open up your wallet. Make sure you're on the XDAI, and look, they should be there.
It's easier than that. It's easier than that. Look up your address on Block Scout.
Block Scout?
In fact,
oh wow.
Yeah. In fact, you might have a few. You might have a few Impact hours.
Yeah, you're gonna have a few extra. I totally fucked up the dispersal.
Yeah, you can just go to blockscout.com and go to XDAI, and it'll there's a you're on XDAI, and then you can just put in your address, your common stack address in the top corner there. And in the end, you don't need to know that you have the tokens. The token log will show you that you have the tokens.
I don't know if this is my address that I have registered.
Yeah, it's probably not. That's probably not your CStack token address.
This is awesome, though. I'll have to check into this. Yeah, good job, guys. I'm not gonna go through all my wallets on while we're recording. But that's pretty epic. I'm excited to check that out. Okay. So yeah, if everyone wants to pop open the attendance sheet and get some emojis going. So how I was just saying how I usually navigate to that, just through the Tech Labs channel, pin at the top is the Notion workspace. I'm getting a little bit of feedback from maybe Sem?
Probably me. Sorry.
Oh yeah. It's always Griff. Okay, awesome. So I think everyone's tracking 6 minutes in. So from the Notion page also, just a reminder, so we have the YouTube channel here, and in the calendar we have a dedicated page for each lab. And so today we have Lab 6. And these are open for comments, so as we go, you guys can actually, if you have questions, you can just post them in here. You can post them in Discord too, of course. If you find that maybe we go over something particularly interesting or useful, you might want to pop a resource in here. Or yeah, just feel free to contribute to these in any way that you see fit as we go through. So this is the Tech Lab, let's see, Tech Template Customization. And I think the tweet headline, the Twitter headline was actually dashboarding, tokenomics dashboarding with Python panel. So we've been doing this for a few weeks. So this is kind of it's in a more mature state now. So what we're gonna do, I've got 20 minutes scheduled. I'm gonna give you an overview of what I've got. I've been tinkering with this stuff quite a bit. And I've got quite a few different ways that we can visualize things like the parameters, the outcomes of the parameters, and then what I think is really important that we can tie into this is like probability distributions. We can say, okay, what's the distribution of voters who are going to vote? Or you'll see we're going to go over the distribution of impact hours. It's a pretty interesting distribution, definitely not a normal distribution. You'll see that most people have in the range of 1, 2, or 3 impact hours, and then there's some people who have like 250. So it's this sort of skewed like beta distribution, but that's super interesting. I think that's a natural fit actually for any community, so it's nice to see those things emerge. And then we can play with those distributions to see how the hatch can play out given the parameters. But it's still early stages, so that's why I've scheduled a nice 40 minutes that we can all do a collaborative build session together after you see the first steps that I've been working on here. And really important to open up, this is awesome. Me, Griff, and Jake, and I think Tonga, a couple helpers, we hashed this out. So this is the guide that we're working on, and you can see this in the Lab 6 page on Notion. It's linked in there. So you can see what we got last week were these widgets that we can interact with. And so what we were doing is saying, how can we refine the language here? How can we make this more simple so people know what they're actually configuring? And then what kind of visualizations can we come up with? What kind of questions can we answer is really the important mindset to have with this stuff. And just some examples and some notes on how we might be able to visualize some of these things. So this is really the map of what we're going for here. It's not fully built out. We'll see how far we can get in the collaborative session today. And this is Griff's take on it. I like this. So the kind of the moonshot goal here is, can we make a fully templated white paper so that anyone can clone one of these notebooks, copy one of these notebooks, and play around with these parameters, and when they get a result that they're really happy with, or they've put weight on the parameters that they think are really important, then ideally they would just hit a button and it outputs a white paper that specifies their whole crypto network and all the parameters and everything like that. I think that'd be so cool, and seems like something we could strive towards. So this is a really good reference document here. Probably keep that open in another tab. Let's see.
When you say you click a button and you get a white paper, what are you exactly referring to? Because in my mind, it was like you click a button and you get the a JSON with the parameters, so you can plug it into a script that creates the DAO.
Oh yeah, that's even better. Yeah, better than a white paper is the actual, like the Gardens template. Really, just the parameters go right into the Gardens template and launches a DAO. That's even next step.
Yeah, the basic idea, Sam. I mean, that would be the next step. That's what you got to work on, Sam. But the general concept is that when you click a button and then you get an editable, like maybe like a config file that you can change some numbers, and then you get all these graphs, all these scenarios, all these questions answered in, a white paper might be a stretch, but at least a specification, right? Where there's all of these graphs that explain what the outcome will be of what the potential outcomes would look like if you choose those parameters.
Okay, what I will say from my perspective, it will be easier just the JSON, but do whatever you have to do.
Well, a JSON's easy for you, but what if
But it's the same thing, Sem. It's the same thing. We output a JSON and we send that to the little microservice that can populate a white paper, and that same JSON can go to the service that can actually deploy the DAO. So it can be this kind of standard. Oh wow, it's like a DAO hatch object, and you pass that to the white paper factory or to the DAO factory.
Yeah, in the end, the intended user is Livia, Jess, like non-developers that want to still be able to choose parameters and be informed on what their choices mean. That's the intended user.
Yeah, my initial idea was that the Jupyter notebook itself is the web paper. So what you are doing is to running the Jupyter notebook, and all the graphs are there. So
yeah, that's what we're going. That's the realistic. That's the sort of MVP, and that's what we're gonna go towards. But it would just be a sort of a fun data science spin-off, not even necessarily data science, but just a little bit of like template programming to make a white paper template and take this one step further past the notebooks. But we're definitely not getting to that point in this lab, so let's not get too.
Okay.
That's a moonshot idea, but I like your idea too, Sam, of just populating a DAO directly. So I just want to guide people's attention a little bit. I was playing. You might have seen me posted in the Tech Labs channel, and there's a branch here. It's called Poetry, which is nice, and that's because it's using a library called Python Poetry. That has beautiful documentation, very inspirational, and really cool open source project. It's a newer kind of Python package manager, and so it's like poetry add your dependencies. You can build and you can publish, which actually this launches your project onto PyPy so people can install it. You can get a dependency tree visualization, and it uses this new kind of file called uses a TOML file, and it locks your project as well, which something like pip doesn't necessarily do. So it has all the information that it needs to actually deploy your project as a package, like on PyPy. So this is a pretty nice system. I'm playing around with it. It's new, so I'm not trying to shill it too much yet, but it's nice if people go ahead and use it and see if they run into problems. So this is sort of the working branch that I'm on now, is this poetry branch, and so it has the install instructions using poetry, and it's quite simple. The poetry install itself was easy, and then using poetry is quite easy. You just have to remember to activate your shell, and that's going to put you in the Jupyter environment so that you have access to all the libraries you need. And you saw that I ran that here, so I just called poetry shell, and then that gave me like, let me split my thing here. Okay, and so if I go poetry shell, it actually brings up an interactive option here at the bottom to select which virtual environment I want. And so I just hit enter, enter, and then there's a little bit of a glitch here because I'm using the fish shell, so it's duplicating this. But anyways, you can see now that it's activated. But just a little note on poetry. So before we get into the hatch template, I think I have this here, which is just, this is actually where we left off last time. So and I've added quite a bit to this as well as I was experimenting. So let's just go through this as a reminder. So we're looking at the dandelion parameters here. So we had support required, min acceptance quorum, and time it takes to propose a pass. So we had aggregated a few of the parameters, the time parameters, into a single one. That wasn't finally decided because we were thinking, well, maybe people should really get to see the actual parameters. We can come back to that in a bit. So here's a hatch. So we have these constants, which we said are the total C-stack tokens, the hatch oracle ratio, the min goal, the max goal, the hatch period, the hatch exchange rate, which I believe we said actually that we're going to take that out, and the hatch tribute. So then we have some impact hours here. And I think this is what I want to show you guys. So this is using the same visualization library that we're using to get a lot of these things, just to render tables. So we can kind of render tables side by side. This might look a bit cluttered, but we have essentially the two different versions of impact hours here. And I apologize if my screen resolution isn't that high on the stream if you can't read this, but here we have an ordered list of all the community members and their associated impact hours. So of course that's very useful for modeling. We can later calculate how many dollar amounts this could be given the price of the token and the impact hour distribution model. And then over here we have more summaries of rounds. So for each round, 2, 3, 4, where I believe a round is 2 weeks. Then we have the total impact hours accumulated, the cumulative impact hours. So this is like growing over time, and we'll see that plotted. The min goal. Okay. Griff, do you want to speak to this a little bit? What was this min goal here? I can't quite expand this. Oh yeah, here we go. 15. Oh yeah, min goal at 15 die per hour. Oh yeah, this is awesome. I want to get back to this because this is saying given this many total impact hours, this is how much we have to raise. Actually, it's the cumulative. So it's given that we've have 624 total impact hours so far, then we need to raise 62,485 die in order to have a 15 die per hour minimum wage and a 15% tribute. So this is a really good data set, and this is actually really readable through just going directly to the Google Sheet, which you can find through the Notion page, I think on lab 4 or 5, this is linked. And so these are the kind of options that we want to be visualizing with these templates, is the scenarios. So let's say we had, 2,000 impact hours total, how much would we have to raise to have this minimum wage? So these can be some selection options that we implement in a bit. Is like what sort of minimum wage is the community member comfortable with? Mm-hmm.
It's worth noting that we have about 3,000 impact hours now. So that's where we are today.
Nice, that's great. So I just made this is a little sort of. This is not directly related to the hatch. This is just what's called a beta distribution parameter, a beta distribution. So we can play with these parameters here to see how the distribution changes. And the reason I'm using this is because you'll find I'm not sure if I have it down. Oh yeah, this, yeah. So this is the actual impact hour distribution. So we'll see it starts at 0, and so the majority of people have this between like 0 and 20, 25 impact hours. And then there's a distribution of people that have in this sort of 25 to 50 is a pretty significant amount of members. And then there's a small amount of members who are essentially the core. These would be, maybe the stewards or like Sam, of course, Santi, Zeptimus, people who are busy doing either technical development or Santi's involved in a lot of different places. Zeptimus, of course, doing all the recording and everything. So we can see that given certain, and we could do some further analysis on this later. That would be really interesting to see what kind of roles are the roles that end up accumulating the most impact hours. And so that's why I was playing with this beta distribution here, is because we could move this, so we could say, okay, what if this distribution shifted? What if we actually had most of our members in this 50-hour range or in the 25-hour range? Or if we had more of a flatter curve here, a sort of more even distribution. So we can make theoretical scenarios where we have different types of sort of work distributions, and I think that's not this is a nice to have. This was just me going off and playing around. This is more of a nice to have, but I'm hoping the code is here. So this is in Lab 6 Hatch Parameters, which is the notebook that was just very experimental for me, playing with different ideas. So you can take this and run with it, and we can use it later. So here we have the impact hour distribution. Here I was playing around with this concept of a simple like stock rendering. So if you've taken the Value Flows ecosystem design course, it's all about stocks and flows, right? So this is kind of a fun way to visualize what a stock might be, or actually I use this later in the dandelion voting, so we'll see that, how we can use that. Looks like this was just some. Oh yeah, this is a different use of a beta distribution. So we can use this to model essentially impact hours, but perhaps other things as well. So the code's there for inspiration, and then this is the impact hours that we saw earlier. And what do we got here? This was me hacking around. See, some of this is kind of. I didn't have that much time this week, so I didn't get all of these completely cleaned up, but this is something I was going for, and I don't remember it to what extent I got this completely working. This might be something we build on in this section, but I think it would be fun to see this curve actually move, sort of bend. If we can bend this curve between an optimistic impact hour scenario and an actual impact hour scenario, and then we can take this and we can multiply it against certain things like, we can use this to live out the scenarios that Griff had documented here. But this is still in kind of a working phase, just going through this so that you guys can see the potential of what we can work with here. And then here we have the impact hours formula that we rendered up 2 weeks ago, but I haven't come back to it, and it would be nice to sort of connect this into the rest of the ecosystem and see how that plays out. So I think that's mostly what we have, and so we're going to use this session to just see how far we can get. It's getting a little bit complex at this point because we do have, the higher you build, the more abstractions you create, the more sort of prone it is to the details. But I think so this is a rough notebook with a lot of just inspiration of what we can do. Now I've got this one here, which is the hatch template, and this is the first iteration of a nice clean hatch template that we can start to play around with. And so this is where we want to start moving towards. Is what we have here is more of a quite comprehensive sort of dashboard, and that's the title of this lab, is Tokenomics Dashboarding. So this is for the dandelion voting, and I was able to put this visualization together. It doesn't look like much yet because minimum quorum defaults to only 2% of token holders, but we can start to play with these values. So this is minimum quorum required, and in this case, I've fixed the number of tokens to be 1 million. And we can play around with this minimum quorum quantity. So we could even say, let's say we could set that at 50%. And then we have the support required, which is the number of votes that have to vote yes in order for that vote to pass. So given that minimum quorum is 50%, and if we set support required to 50%, then we see that 50% of that quorum has to vote yes. Oh, and this is cool. I actually was able to go, a little side note. So if we go GitHub TE Commons, then we have the branding assets. I love this repository. This is so useful. We have logos, all sorts of different stuff, typography even we could use. But I just went into these colors and grabbed these hex values, some of these hex values, so that we can actually use them in our charts, which is fun.
Yeah, that's super cool.
Yeah. So it's this, when we're using HV plot to make the charts, and after we create our plot, so this is essentially a fully created plot, and then that object has this .ops method to set options, and we just say color equals HV. HV is our HV plot library, so HV.cycle, and then we just give it a list of colors, and it's just going to cycle through those colors. So
there is one thing, if we can fix that the quorum is for the yes votes, not for all the votes. And I don't know if it will be, it's something that it should be fixed, but I don't know if it's the moment or maybe later during the session.
I think that is a good exercise. We can try to tackle that, and I'll keep. Actually, this is mostly all of what I have here. I started putting this idea together of a community participation model, and that's where I was going to have the distributions, like percentage of token holders who show up to votes and things like that. That might be something we tackle, but I think this is good, Sem. I think I'll just finish going over what we have here. So support required, and then these I added. I haven't visualized anything, but essentially days to vote on a proposal is the way that I interpreted these notes here. If you go into the notes, let's see, tech model spec. So we had a few different discussions on how to sort of compress these vote duration blocks, vote buffer blocks, vote execution delay blocks, all into perhaps a single. Yeah, and as I was working on this yesterday, I was coming back to this idea that I think in this, what we're doing here should be prioritized towards simplicity and understanding instead of exact technical precision. So because it'll allow people to sort of exercise their intuition. So it's like important that people do understand, what these three different parameters are. But what we want to do here is gauge the community and sort of their perspectives and opinions on the hatch and what they think is important and what they want to see. So for that reason, I started going with this sort of abstract these away and just give a few simple, very intuitive parameters. So I had things like days to vote on a proposal, days to exit a hatch, given that someone's not happy with a proposal, and then cost to make a proposal.
Yeah.
And maximum number of votes per year, or maybe this should be, votes. That could be confusing. It's not like individual votes, but proposal votes. Maybe I would say proposal votes.
Maybe proposals?
Yeah, I'll just say proposals. Yeah, that's better.
And maybe it should be months because it's it sounds quite weird.
Yeah.
To think on
You're-
it's going
yeah.
to. Because it's weird to think that it's going to last 1 year.
Yeah, because do you mean before the upgrade, basically?
Yeah, the optimum way is that the first proposal is the one that passes.
Mm-hmm.
But if it doesn't pass, then there is that execution, that delay period, or I don't remember now the name, in which you have to wait until a new proposal is ready.
Is it the buffer blocks?
The buffer blocks, yes.
Right, so you can kind of combine these three parameters into this concept. Well, that's how you can calculate the maximum number of proposals per month, right?
Yes, because you have to, but in that case, it's adding the both time and the other one and the buffer blocks.
So moving this days to vote on a proposal should actually.
I don't think so, Sam. Not. I've looked into this a couple times, and I'm pretty sure that it's just for proposing them, not necessarily. It doesn't include voting period.
Ah, wow! I didn't notice. Then it's better.
Okay, so multiple proposals can be open at once. So
yes,
you-
but they can only be
Yes?
proposed within, like, if one proposal is proposed, then it takes the vote period buffer blocks or whatever, a number of hours before the next one can be proposed.
Yeah, that makes sense.
Okay, I did that wrong then. I had that wrong.
Oh yeah, so the final piece of this over here is as we change this quorum and support level, we get over here minimum tokens to meet quorum, and we'll fix this up a bit as you mentioned, Sam. But so we can get an idea of how many tokens need to show up. And this might be, you might say, well, what percentage of tokens is that? Well, it's just our quorum percent. So you can look at this actual number to say, oh yeah, 86% of tokens need to show up. But to get an exact amount of tokens, you can see over here, and then the minimum tokens to pass a vote and the minimum tokens to block a vote, and those will change depending on our support level required. So Sam, I think we should go through this and yeah, let's get this minimum quorum precise if we can. So go ahead.
I love to understand better the code, because I love the graph, but then when I go to the code, it's like, what's all that? Total tokens, minimum quorum. Those are all the params.
Yeah. So here we have all the params. So yeah, total tokens is just fixed. We have the minimum quorum, support required, days to vote on a proposal, days to exit the hatch, cost to make a proposal, maximum number of proposals per month. And then we have this view, which is giving us everything here. And so what we do here, first we calculate the minimum number of tokens to pass a proposal. And so I have, it's the support required times minimum quorum. And this gives you a percentage of tokens. And then I times that by the number of tokens to give an absolute amount. So that's what we see here.
It's all multiplied?
Yeah, support required. Okay. So if support required is, say, 50%, and minimum quorum is, let's just imagine 100%, then so far we have the support required would be 500,000 tokens.
the thing is that we have to count only the yes votes. So, but I mean, what we are trying to change is the mean support, right? Mean tokens to pass. I'm still trying to understand. I'm sorry.
No, that's okay. Me too. I'm trying to understand because that seems complex to implement, like the min quorum given the yes votes. So maybe we should make a scenario. So
I think not, because we can. I think that's not that difficult, because you have to take that support required. I think that it's just multiply that quorum per the support required, and that support required is going to be maybe 0.5, which will make it, but I'm not sure. And what I say is that because you are counting the yes votes, then the yes votes are that support required. So I guess that mean support is, but I am confusing the terms. Mean support is the support required. What you
oh no, okay, yeah. This is so. Min support is actually minimum number of tokens. So minimum yes tokens.
Okay.
Or yes tokens required.
Okay. So the last line is the graph, and we have that column min tokens to meet quorum.
Yes, okay. So this is the final output. So what you're seeing here is it's a row. So this is how we use Python panel. It has these essentially three functions. Panel.pane, and we can pass something like our dandelion voting instance. So when we have a parameterized class and we pass it to the panel, this is Python panel here, then ultimately when panel renders, it gives you a pane. Like what we have here is a pane. So the final view is a pane, but it can be composed of rows and columns. It's almost like Bootstrap if you use Bootstrap. So we can make a row.
Okay.
I wonder if this will work. Yeah. So we could have as many things here as we want. Oops. Oh, missed a comment. You can even put, I think you can put like HTML in here. Or there's some way to. Oh yeah, you can even put HTML right directly in here. So it opens up a lot of possibilities for doing cool things. And then we can make a column as well, and these are composable. So we can go panel.column, and then we could go so d dot. Okay, and then what we have here is so when we have these parameterized classes, we can make a function that returns some sort of view. And so I've called this the view function because we make this plot and then we return a row of the plot and some statistics over here. So let's just, and we pass it as a function. So we get this. So we have our row here and our columns like this. So we can start to compose dashboards in this way really nicely. So we could actually take our hatch, we could have our dandelion params, our hatch params, and our maybe impact hour distribution. Oh yeah, impact hour function here. So this is cool. So then we can start to get sort of a comprehensive dashboard of everything that's happening. So maybe we'll do that.
Yeah, that's going to be super cool.
Yeah, this didn't even click for me until now. I'm like, whoa, this looks amazing. Okay. So I have some stuff I'll have to bring in. Let's bring this in. This is awesome. I can delete this. Just hatch. Okay, where's our hatch object? Here we go. Just trying to stay kind of organized as I go. So let's just take this. That's the thing with Jupyter Notebooks. After a while, you learn how to keep things ordered because they can get really confusing because you always have to run them basically sequentially. So if you end up running things out of order, then it'll seem like everything's broken when you might have just missed a cell that you're supposed to run. Okay, so let's bring this up. So we've got our okay, just put this here, the hatch, and well, let's just take a look at that. So we can say h equals hatch and try out panel.pane on our hatch. Okay, so we get those parameters there, and then we have our impact hours. And let's take a look at that. Panel.pane. Oh, we have to instantiate it. Impact hours and panel.pane I. And we have the view there, so let's go I.impact hours rewards.
And that view, in the other pane, you did it in another way that showed itself or not? You say d.view.
Oh yeah. So that is, yep, it's always just, it doesn't need to be called view. This is just any function that returns something that can be sort of visualized. And then this is where the composability comes in handy because you can always return any sort of panel object. So this can return a row and it can be put into a column when we actually go ahead and use it. But it's just one thing because it's actually passing a function if you notice, because what we're doing here is like d.view is actually a function. Like if we put parentheses here, then it would call the function and return this. But we're actually not doing that. We're passing a view function into the panel column.
And it calls itself.
Yeah.
Pane calls it.
Yeah. Pane's gonna call that internally. Yeah. So I'm just stuck on this one now. What's happening here? Pane. Oh yeah, we can't. That's easy. Oops. Total impact hours. Oh yeah, we gotta load a little bit of data here. Total impact hours. Cool. Okay, so let's see if we can put these all together now. So panel.row. So we know that we have our dandelion and our dandelion view. How did I think I deleted what we had before. It was actually kind of nice. I should have kept it. Oh, maybe I can. No, it's gone. So let's get all of our parameters actually in one place. So let's just go D, H, and I. Okay, cool. So this is nice. Yeah, okay, this is looking good. So then we can get our results, which are maybe d.view. The hatch, we don't have any visualizations for the hatch parameters yet. We got 15 minutes here, so let's see. Okay. And the impact hours, we have our impact hours chart, which is impact hours rewards. Okay, so we can start to play around with what this is going to look like.
Wow, that is so cool.
Yeah. Yeah, this whole stack is really amazing, the PyVis stack. It's definitely underrated. It has a ways to go yet in its adoption cycle. So this is what we got so far. So we could think about combining. I mean, yeah. What do you think, Sam?
Interactive white paper.
Yeah.
This is the dream, right? I mean, if we have these tools, then anyone can really deploy their own commons for any purpose.
We put a button in the bottom, not for doing a white paper. The white paper is that, and the button on the bottom is going to be deploy.
That's pretty amazing. Well, really is possible if we take this, and run with it. I would love to see the lab contents be spun off into, because probably 1 hour a week isn't enough to fully develop if we want to do various ambitious projects. Like that's totally possible. We could have a button here that hit, we could, because we could just have, we can pass around JSON. We could use the Python requests library to hit, or we could use actually Web3 Python or something to hit Ethereum directly. But that'd be really interesting. That's to start to connect to these ecosystems and get them.
I think the JSON is okay, but actually it could be also possible to use Web3. It will require three or four transactions, and this is why we have a script. Actually, even more, because we need to load the impact hours into the blockchain. So I think that it's much more safe to do that in a script.
We might Sam, we might make impact hours a token.
Okay. Yeah,
so I don't know if that makes it easier.
You did that, right?
Yeah, we started to do that. Yeah. I mean, the token is there, but we may need a new token. Who knows, right? I'm not going to say this is the final token.
Okay. We were loading it as a mapping. I think that it's not the moment, but we can whatever. It can be a token or a mapping in the Solidity. It doesn't matter so much right now. But yeah, the thing is that I still think that the easiest way is to create that JSON, and maybe in the future we add a button that deploys the DAO. I don't know.
That's incredibly exciting, yeah.
One quick thing from our front-end designs that we're working on with Fiore, and I think it also makes sense for quickly communicating to the people who are voting on these parameters, like the idea. But I think it'd be nice to force the person creating the proposal to also have a target goal. Like there's the min goal and the max goal, but how much when they're designing this, how much do they actually think we're going to raise? Because I would assume they're going to design for that. And if we ask that question, it will force them to design with that in mind. You know, like.
Yeah, we could say expected goal or optimum goal.
Yeah, I would put it as expected. You know, it's like, what are you designing for? Like, what is your design?
Hello, YGG.
Hey, Tonga.
Can you hear something?
YGG, your code is hot. I love how you code Traducion. Let's do 5 hours a week.
Cool. All right, Tonga, you want to sign up for 5 hours? 5 hours a week. Well, we could make a lot of progress.
Yeah.
Yeah, let's think about that, Tonga. If we can, so maybe we can have sort of an offline lab sessions. We could have. It's almost like the working groups, right? They have their sort of offline check-ins and everything, and then they have a central meeting. So this space could be sort of the community lab session where everyone comes together. We can do really coordinated builds and lectures and special guests and things like that. But then we could also have sort of more of a core group that meets does like these working groups, because that's kind of how it's been for me. I'm putting in a few hours, probably about 3 hours throughout the week to like really get my mindset already on this, and then have it ready to go through the lab session. So it would be much better, much more productive to have it not just me doing those preparation sessions. Although Jake and Griff have been really helpful in guiding this. Like we made this whole doc, which was awesome. Oh yeah, Tonga, you were there too, I think. And but yeah, we can do these sort of preparation lab sessions throughout the week, Tonga. So let's set that up.
Yeah, okay.
Oh, Tonga, I might have found a third programmer for the Django build.
Yeah, I'm currently focused on one issue, and it takes me a lot of time, so I don't know how much time I have. Like, I'm very, very slow.
Well, maybe I can help with that too.
Oh, okay.
The reason that we can fix that I don't know if we will have the time or that is homework. But with the 7 minutes that we have, maybe we can try to fix that book, the Quorum, and try to understand better.
Yeah.
I don't think that we will have time for anything else.
Yeah, that sounds good, Sam. So I think we should, maybe we can make this from scratch. So let's imagine we have this dandelion voting. So we'll keep this fixed total tokens. And so is minimum quorum, this makes sense, right, to be like a percentage?
Yes, and that's the percentage of yes votes.
Yeah, okay, so how do we model this? I'm getting stuck already a bit. So how should we have should we say this yes votes or?
No, it's called minimum quorum. Minimum quorum.
Mm-hmm.
And I think that last time in the last lab, yeah, I said it's important that the quorum is less than support or something like that.
Yeah, it's here. Oh wait, no. Oh, this is the hatch.
Do you have it?
Yeah, I have it here. But I was considering this so deeply throughout this week when I was building, and then I realized, wait, this can't be true. I took it out. I thought that doesn't make any sense to me, but that probably just represents I'm a bit confused. Because I understand the support to be a percentage of the quorum, essentially. But I think maybe I'm missing something.
You probably didn't took that as true because you were considering quorum as the sum of yes and no's.
Oh, okay. Okay, so maybe we need to start with support instead of quorum.
Okay.
So let's forget about quorum for a moment and say, what really does this support required? What does this mean?
This means that you need at least of everybody who has voted, you need at least 50% of people voting yes.
Okay.
And you had it right.
Okay, so 50% of votes or more must be yes votes for this to pass. Now, okay, so now let's consider minimum quorum. So let's say that in this case, we require 50% of votes to be yes. Then is minimum quorum, is it a percentage of all tokens? 2% of all tokens?
No, it's only a percentage of the. No, it's a percentage of the ones that voted yes.
Okay.
Yeah.
I think no, or not.
No, it is. You're right. For dandelion voting, you're right.
Are you sure, Griff? Because we have, for example, 2% of quorum in the DAO that we have been testing, and it was not like the people who voted yes. It's like, I think that what I just said that doesn't have sense. You need at least 2% of people who vote. But the thing is that the people who vote no, I mean, that's of all the votes, you need 2% of all the possible
tokens to vote yes.
All the tokens.
Yeah.
They have to vote yes. Exactly.
Yeah. Here we got it. Okay, it's actually so simple. Why? Okay. So we have 2 minutes. I'm kind of curious if we can get this. That was a little breakthrough. This is making sense to me. Of all the tokens, 2% of them have to vote yes, and of all the tokens that vote, at least 50% of them have to be yes. Cool. At least this is clear. I don't know if we'll visualize this in 2 minutes, but at least this is clear now. But I'm just gonna think about this a little bit. So 2% of all tokens must say yes. So basically, let's imagine this visualization. We would say, based on 1 million tokens, support required. Then I think to make this visualization make sense, we're gonna need a parameter that's like number of.
No, that visualization makes sense by setting, if you have, for example, a 50% of and the quorum is the people who votes yes. I mean, you need that. Right now, the quorum is the sum of yes and no's. So, for example, right now you have a quorum, right, of 45%, 46%, and that means that the yes tokens should be at 46%, 45%.
Of the total.
And in the graph, that should represent that we have 46% of tokens that votes yes, and this is why quorum must be less or equal than support required, because now is that right?
Yeah, no, that's absolutely right. The quorum has to be less than or equal to support required. That's even in the code.
Okay. So I think that the idea.
Yeah, because if quorum was higher than support required, you could get into a case where you have support, where the support is passed, but the quorum is not met.
Well, what I try to say is that the blue box should be equal to minimum quorum. Does it have sense?
I'm going to make this, at least I understand this now. I understand why. So minimum quorum is the percentage of all tokens that must vote yes, and support required is the percentage of votes that must be yes. So to me this is so clear, so I'm gonna take this and make it work in a visualization. And I'll post a screenshot and I'll push that to GitHub, because I know if I can get this visualization going, then it's gonna be really clear. And I might make it might have to be two different bar charts instead of stacked. It might make more sense to have them independent.
Okay.
And then we'll see that property, and then if they're independent, we'll see that property where support. Wait, what is it? Quorum cannot pass support.
Okay, I still think that it can be done in just one, but I'm not sure. So and I need time. So let's see how you say.
Yeah. Okay, thank you guys. We're a little over 2 minutes over, and this is so cool. So I'm gonna push this. We're getting towards. I want to check in with you guys, Griff, and with the sprint planning and everything, and line up this development so that it really lines up nicely with what's being planned for the hatch. So we'll just have a chat about that.
We can also when we meet up on the weekend, we can definitely go through a lot more of this.
Yeah.
And then we can really have a timeline planned.
Perfect.
Because I'm also getting some good feedback from Wes. So I think, I think we're gonna line up just fine. But we can hack out more on Sunday and go from there.
Awesome. Thanks, Jake.
Yep.
I love the lab. GG.
Yeah, I think it's great, and I'm excited to get more people signed up to have some guest lectures. I'm going to start working on that more.
Nice. Hey, thanks, YGG. See you guys.
Thanks, everyone. Thanks, Griff.
Thank you so much.
Thank you, guys.
Thank you. Bye.
Thank you. Hey, Liam. Oh, he just dropped. Okay, thanks all. I'll see you soon. Hey, Liam. Tonga.
There he is. I heard "Hey Liam" as I was closing.
YGG.